there, welcome to a college mathematics video. In this video, we're going to get our introduction into the chapter on sets. So within our first section, we're going to focus on two objectives. We're going to look at learning the properties of sets and then three methods to indicate sets. The study of sets is important because it helps us classify different types of information. So if you can imagine an example, there's lots of different ways we could classify a place like McDonald's, for example. One way might be to say that it's a fast food restaurant. We could say we want all fast food restaurants. McDonald's would be one of them. Another way would be a place that sells hamburgers. Another would be a place that sells breakfast. So the study of sets is looking at comparing those things and kind of being able to manage large amounts of information. All right, so into our first section. So the two objectives: learn properties of sets and then use three methods to indicate sets. As will usually be the case, the first section within a chapter will be a little bit definition heavy because we typically have to lay the groundwork, lay the framework for what it is we're looking at, and then actually start to do things with it. All right, so let's look at that first objective, the three ways of indicating sets. Before we get there, let's talk about what a set actually is. So here's our formal definition for a set. A set is a well-defined collection of elements or members. So well-defined collection, elements or members. Elements is the word I'll typically use. Okay, in order for us to really understand that, we need to have a better understanding of what well-defined means. So let's define that. Well-defined specifically means that the contents can be clearly determined. Contents can be clearly determined. So a well-defined collection of elements or members, meaning that the contents can be clearly defined. Let's give a good example and a bad example of that. So a good example of something that is well-defined is if I were to say, what are the days of the week? If this is the set I'm looking for, days of the week. Now, there are technicalities on all of these things. If I said days of the week, you were born in another country, you might say, oh, we use different words for these days of the week. I don't know if there is, but there might be another culture that has different days of the week and a framework for how things are set up. But assume that we're here, assume that we're in the United States. So when I say, what are the days of the week, our answers should be the same: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Now, you might not necessarily say them in that same order, and that's okay. But as long as you're getting those 7 elements or members, we're good to go. We all know what we're talking about when we say the days of the week. That's a well-defined set. A bad example would be something like the top 3 vacation spots. This isn't clearly defined because my answer to this question would be different than your answer. So, depending on who you talk to, you'd get different answers. That's why we want to stick with something that is well defined. All right, so then we have 3 common ways to indicate sets. The first one is through a description, and this is as simple as it sounds, a sentence describing exactly what the set is. So a description could just be simply the set containing the days of the week. The second one we have is roster form. I'm going to put some stars next to this because this is the one that we're going to use most often throughout the rest of the chapter, but in this section specifically, we'll definitely see a mixture. And throughout the chapter, you'll see a bit of a mixture, but we definitely will rely on roster form more than anything. And then the third type is set builder notation. And this one is most commonly used in algebraic type classes. We won't be doing any real sort of algebraic work, at least in this chapter, but you'll see it a tiny bit elsewhere. But this is the third kind. So what we're going to look at next is each one of these 3 in a little bit more detail. And the ultimate goal at the end of this section, one of them, is to be able to make translations from a set from one to the other. So if I give you a description of a set, you should be able to give me that set in roster form and then potentially also in set builder notation and vice versa. We can start anywhere and move to the other three. These are just three different ways of conveying the same information, conveying what is the set, this well-defined collection of elements or members that we're talking about. All right, so let's go ahead and look at that first one. So the first one we'll look at is description. So an example description is the one here we have. Set B contains the 5 Vietnamese cuisine balance elements according to this website. So this is the example of the description. I don't really have a great example other than this. It's as simple as giving that description. And so then those elements, according to the website, are spicy, sour, bitter, salty, and sweet. So the second way that we have it presented here, this is actually roster form, one of the other ways that we'll write it. So you could be presented with set B in roster form, spicy, sour, bitter, salty, sweet, and then be asked to make the conversion to description. Set B contains blah, 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 as you see there. Your description can vary from person to person. Obviously, just with anything, people can describe things different ways. So there's no one simple way to describe a set. All right, so then let's look at another one. If the set, the given description is set A contains the states of the United Kingdom, you've got a picture there in case you're not familiar. The elements for this set, according to the picture, would be Scotland, Northern Ireland, Wales, and England. So you'll notice with roster forms, there's not really much we can say about description. You'll notice with roster form, we've got these curly braces on the outsides, and then we just list the items in there. There's no particular rhyme or reason to the order that the items are listed in there, as long as they're all listed there. So again, the description is what was given in this case. You'll be asked to go back and forth, so sometimes you'll start with one and go back to the other one. And I want you to know that, especially for two examples like this, I wouldn't expect you to be able to know what those 5 cuisine balance elements are. I'm presenting an example to you so that we kind of learn something about other cultures, but I would never ask you, I would never give you this question, here are these elements, and then say, give me a description. How would you know offhand that that's exactly what those things were? This is just an example of how it could work. And the same with the states of the United Kingdom. It's not an expectation of mine that you already know what those are. I might present a picture and then have you make the conversions. But just so you know, and you're not afraid of, the types of problems you might see. All right, so this kind of gives us a summary of description. It's as you would expect, describing it. Let's look at the second one. The second of our 3 forms is roster form. Again, this is the most commonly used. And so let's just start going through some examples of them, and we'll kind of pick up the ins and outs of this. So the first one is to write the set of natural numbers in roster form. All right, this one specifically, again, what's presented to us is the description, and we are taking this information and changing it to roster form. So in any case, when you're going to roster form, you have to have the set name. It'll be typically 1 letter. We don't have a letter listed here for our set. You see in the next one we have it called set A. So for this one, we're going to go with the letter N because what we're doing are the natural numbers. You'll put equal and then open, a brace, it's a curly brace, and then we fill in what those elements are. So we're looking for the natural numbers. You may or may not remember this from your algebra class, and I promise you this is the only one that we'll really see here. There's 2, but they both mean the same thing, of those kind of algebraic ways of describing numbers. And the reason this one is used is because it's really basic and nice. So the natural numbers start at 1, 2, 3. They're your really clean, nice, whole, positive numbers. 6. And these numbers continue on forever, so we put the ... the ellipsis. A couple notes about this. This is the set in roster form, but just a couple notes to add about this. The first one is that this set does not include 0. So when we discuss natural numbers, 0 is not part of the picture. A reason that you'll see natural numbers used most often is because these are nice numbers. If the problem itself just said write the set of numbers in roster form, we would technically have to include every decimal, every irrational decimal, every whole decimal, every fraction, every single number that exists ever, and that's basically impossible for us to list down. So imagine if 1 is the first thing we wrote down, we'd have to have 1.00001, 1 point, every single decimal leading up to 2, and then all potential fractions that certainly could be written as decimals in between. So in order to avoid that kind of problem, we just always go with the natural numbers, which are the nice 1, 2, 3, 4, 5, 6, blah, 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 forever. Okay, the second note for this one is that these are also known as, aka, the counting numbers. So you know that if you asked anyone, if you ask a child, can you count for me? They're going to say 1, 2, 3. They're not going to start with 0. So that's hopefully another way for you to remember that 0 is not included. Natural numbers, counting numbers, same thing. And then the last note is that the ... the ellipsis you see there at the end, this means that it continues in the same manner. So I wrote down 1, 2, 3, 4, 5, 6, ... Truthfully, you could have stopped a little bit sooner than that. It conveys the same information to write down 1, 2, 3, ... Ooh, let's make those look nice. The ... means it continues in the same manner. So there just have to be enough elements for us to be able to tell, okay, this is the pattern. Writing just 2 elements, 1, 2, it's not really enough to tell me that that's what's happening. I don't necessarily know if everything's being multiplied by 2, if it's constantly, what kind of increase is happening or what the pattern is. So just make sure you fill in enough to convey what the set would contain if you are writing something that does continue on forever. All right, and the ... can be used in the front and the back, whatever the problem asks for. Okay, so let's see a couple more examples. The next one, letter B, set A is the set of natural numbers less than 6. So we have the set name, which is A, equals. We open the brace. This is a key on the keyboard, so you'll be able to find that and see what it looks like to get better at drawing it. Mine are not perfect, and when I'm not drawing them nice, they definitely get pretty ugly looking. So we have natural numbers less than 6. Natural numbers, we know what that means. 1, 2, 3, 4, 5, blah, 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 blah. That's everything going on forever. Less than 6. So it's not quite everything. So we still start at 1, 2, 3, 4, 5. And since it's less than 6, we don't include 6. 5 would be the end. And that's it. Now, you could present this set, this same exact set, if you wanted to, in a different order. 5, 4, 3, 2, 1. If you felt easier starting at that highest point and going lower, totally fine, but you can only use the ellipsis if you're conveying a pattern. So if you were to go this route, I guess you'd have to start with the ... on the other side. I'd say for the most part you're just going to go in order, but just so you know, the items inside of a set don't have to be in any particular order. Okay, the next one on this page, set B is the set of natural numbers less than or equal to 80. So we have our set name, equals, open the brace, then start filling in those elements. So natural numbers, we know what those look like, less than or equal to 80. So I'm going to start 1, 2, 3, 4. Now I can put the ... to say, okay, this continues in the same manner, but it doesn't go on forever. This does have an ending point. So you can sort of imagine the ... is like running through that middle stuff, and then you got to slow down again at the end and tell me, okay, how does this end? And the ending, 78, 79, 80, and then we close it. You might be wondering, could I put fewer numbers in there? Could I list specifically and just use the ellipsis in a bigger way? That's fine, as long as you're conveying the message of what all of these values are. If there's any question on what exactly the pattern is, then you won't be conveying the same information. So you could have done 1, 2, 3, ... 78, 79, 80. You could have had more, 1, 2, 3, 4, 5, 6, 7, ... 76, 77, 78, 79, 80. Anything like that would work. All right. We do a lot with roster forms, so we're going to do a few more examples with this before we go to any practice. So the next one, set P is the set of the months of the year. I realize if, again, you're from a different culture, country, you might be thinking, well, I use different words for these. Just go with, we're in America, use the words we would use here for these. So set P has the months of the year. So we have January, February, March, April. So this is the question. Do you think we can use the ... here? We obviously have quite a few elements to fill in, more than you'd probably prefer to write down. Do you think we can use an ellipsis here? The ellipsis means that it continues in the same manner. And so while in your head you might believe there is a pattern to what these words are, there's not really a pattern. If we were to, bring this to someone from another culture, the numbers would have a pattern. They would say, oh, I think I know what the next, even if you could show them by hand. But there's not necessarily a pattern when it comes to words. So anytime you have words, you're just stuck writing them all. You might also be wondering, can I shorten them? Can I write Jan. Feb. March, April, May, June, July, AUG. It's okay, but it's really preferable to just write everything. Okay, so we have all of our months listed inside the braces. We've presented this in roster form. So the description, set P is the set of the months of the year. Roster form, P equals all of those elements specifically listed out. All right, a couple more. The next one, set G is the set of natural numbers between 2 and 6. We're going to roster form, so we have G equals inside the brace. We want natural numbers, we know what those look like, between 2 and 6. Everything between 2 and 6 would be 3, 4, 5. It doesn't say that 2 and 6 are part of the picture. So if we say between things, we don't include those two endpoints. Compared to the next one, set H is the set of counting numbers. Remember, counting, natural numbers, same thing. Between 2 and 6, inclusive. Inclusive at the end means that those two endpoints are part of the picture. So we have 2, 3, 4, 5, 6. When there's only 5 elements, I wouldn't use the ellipsis. Only when there's a really large number of elements. Okay, and then one more example here. Set K is the set containing the continents on Earth. So we have K equals, and then we fill in all of those elements. So we have Europe, North America, South America, Asia, Australia, Antarctica. What am I missing? Europe, North, South America, Asia. Oh no, the 7th one isn't coming to me. Europe. Africa. There we go. And so for this reason, even I can't remember them quickly off the top of my head. You don't have to worry about expecting a question like that on a test. I like to give questions where we can kind of maybe learn a little bit more about the world and cultures, but I'm not going to ask you questions on a test that would require you to have this outside knowledge that, hopefully you remember seeing these at some point, but I can't expect you to have them memorized and ready to go when it comes to a test. All right, let's move on from this. Okay, so a few more notes before we move on to our third format. This symbol right here that we have looks sort of like an E, but it's very rounded with the line in the middle. This symbol specifically is something you'll see in set builder notation, so we just want to talk about it. And it specifically translates to is an element of. So when you see that symbol, That's what you're supposed to read in your head. All right. So let's look at an example. Given this set H containing these elements, the one we created on the last slide, is each piece true or false, each of these three? So let's give a direct translation before we decide if it's true or false. The first one says, let's call this number 1. The first one directly translates to read, 4 is an element of H. That's the direct translation. Then the question, is that a true or a false statement? Is 4 one of the elements listed inside this set H? The answer is yes, so this one is true. Okay, the second one, we'll move over here to the right. The second one, let's do the direct translation first. This one says 7 is not, since there's a line through it, is not an element of H. There's the direct translation. Then the question, is that a true or a false statement given our set? 7 is not an element of H. This is true. 7 is not inside that list. I'm just getting you used to using this symbol because we're going to see it a little bit. I want you to kind of have a good understanding of what it means. And then the last one, this direct translation, says 2 is an element of the set containing, this is how you could translate this piece, the set. Now you could say natural numbers between 2 and 6 inclusive, or you could just list them. 2, 3, 4, 5, 6. There's our direct translation. Then the question, is this true or false? Is 2 an element of that set? It is inside of there, so yes, it's true. The idea here really isn't to worry about the true false. We'll see questions like that, but the idea is to get used to using that symbol since we're going to see it a little bit more. And we introduce it because it's part of set builder notation. Okay, so let's look at set builder then. Again, this one is frequently used in algebra, and this is kind of what it would look like. Kind of fanned out here. I have it really spread out on the slide because I want to write the direct translation of what this says. Then I'll write it condensed so you can see what it'll normally look like. So let's go piece by piece. This is how you could read this. This says set D, the equal sign you can read as is. The open brace, an element, the set of, hello. When we see the X in this position, we translate it to say all elements X. Then this line, it's specifically kind of a thick, tall line. This translates to such that. And then conditions. Now, these conditions are different from problem to problem, so I'm not going to put it in quotes in our translation because that's not what you would say. You wouldn't read that out loud. You would just say whatever the conditions were, and that would end the sentence. So this line reads, set D is the set of all elements X such that whatever the conditions are. We'll see some examples of that soon. Remember, we're looking at 3 types: description, roster form, and set builder. And the goal is to be able to translate back and forth between all 3 versions, 3 different ways of conveying the same information. So imagine if set builder is what we're presented and you're asked for a description, one way to do that is to give the direct translation. Sometimes that's easier, sometimes it's more complicated. It's really up to you. All right, so let's write this a little bit more condensed in this line. Set D, this is what you'll actually see it more closely to look like. And I'm gonna just fill in a blank line here because whatever the conditions are, what will get filled in. So this will say set D is the set of all elements X such that whatever those conditions are. Like I said, you'll see these in some examples. We'll fill them in and kind of go back and forth from there. All right, so let's take a look at some examples of this. The first one, we are presented this in Set Builder. This is what Set Builder looks like with conditions filled in. And we're going to translate it to the other 2 versions. So this is what it reads, and this also works as a description, but you don't have to be this detailed if you don't want to. So the direct translation of this line in Set Builder says set E is the set of all elements X such that, now the conditions. What are the conditions? Let's write them in some colors here. So the first one we'll write in red. The first condition, do a direct translation of it. X is an element of the natural numbers. There's more than one condition in this case, so we'll write and to pull that together. Our second condition, oh, not green, let's go with black. The second condition very simply reads X is less than 10. And then we'll close that off. So we represented the problem in Set Builder. We translated it, which is one way to give a description of it. So set E is the set of all elements X such that X is an element of the natural numbers and X is less than 10. You could be more concise in that description if you wanted to. Let me give you one quick example of what that could look like. You could just say set E contains, and you just have to hit all those conditions. We have natural numbers, and they have to be less than 10. So all natural numbers less than 10. These are two different ways you could give the description. The first one is a direct translation. The second, just a way to describe it. Either one, totally fine. Okay, and then the third of our three ways, we have Set Builder, we did description, is to write it in roster form. So this is actually listing those elements specifically. So open up the brace, and then what actually goes inside here? Natural numbers less than 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Just less than 10, so ending at 9. So we have all three versions presented here. And like I said, this is kind of where we're hoping to get in this video, one of the objectives, to be able to convert back and forth between them. So I want to give you a little bit of a chance to practice these things. So go ahead, pause the video, try these problems on your own. Remember, this is an important part of the process. You try them on your own so that you've either struggled with it or figured out that you understand it. Then we go through it together. So go ahead, pause the video. I'll see you in a moment. All right, so let's take a look at these. We are given two different problems. We are asked to decide how it is presented and then say what the other two are and make the conversions. So our first problem is presented with Set Builder. The other two are roster and description. So let's make the conversions. Set A and roster, we're listing exactly what those elements are. So we have the set with natural numbers that are odd, that are less than or equal to 7. So we have 1, 3, 5, and 7. Then the description can either be the direct translation from Set Builder or just a description of this, essentially hitting all three of those criteria. Set A contains. You do need to say the set name in your description. That's definitely part of it. What does it contain? It has all natural numbers. You could even say all odd natural numbers. That hits 2 of them already, that are less than or equal to 7. Just makes it. All right. So we have all three: set builder, roster, description for that first example. Okay, second example, we have B with the elements West Campus, East Campus, Winter Park Campus, Lake Nona Campus, and Osceola Campus. For the time being, when I'm recording these videos, these are the campuses we have. And this is presented in roster form. So the other two are set builder and description. So let's go with set builder first. The set name is B. Always start there, equals. This part always looks the same, X, line, and then we fill in the conditions. This is the piece that will vary from problem to problem. So what is a condition for it to be a member of this set? X is a what? They're all Valencia campuses. All right. And then a description, again, can be a direct translation of this, or it doesn't have to be. You can simply say set B contains all Valencia campuses. And that works. Could be the direct translation or not, doesn't matter. Description is just, like it says, a description. Okay. All right, so that takes a look at the three methods of indicating sets. Let's go on to that other objective where we learned some more properties of sets. Like I said, this first section is a little bit definition heavy, but this is where we lay the framework. All right, so some definitions. The first one we have is for a finite set. A finite set contains no elements or the number of elements is a natural number. So a finite set either contains no elements or the number of elements is a natural number. So an example of this, if I said a set containing all the students that have a 7.9 GPA. That's not possible, so your set would not contain any students. That's a finite set, still very distinct. It would also be a finite set if I said all current Valencia students that have exactly a 3.5 GPA. You could specifically list every single student. It's difficult to do that, but you could list all of those students. So the number of elements would be a natural number. You could count it basically. All right, compared to an infinite set, really fancy definition, this is when a set is not finite. So every single set is either finite or infinite. This is one way we can talk about them. So it either has no elements or we can count it, or essentially the elements go on forever. So quick example. If we had a set that has these elements, 3, 6, 8, 9, this is an example of a finite set. The number of elements is a natural number. There are 4 elements. Very distinct, that's all there is to it. Compare it to this one. This one is an infinite set. Essentially, because of the ellipsis in this case, it tells us that the set goes on forever. If it goes on forever, it goes on to infinity. You have, oh, not infinity. You have an infinite set. So every set, finite or infinite. All right, a couple other ways to classify sets. One of them is potentially to have equal sets. So here's the definition for that. Set A is equal to set B notation-wise, it would look like this, A equals B. If and only if set A and set B contain exactly the same elements. And a note about this, they don't have to be in the same order. Okay, so the most important part of this definition, let's underline it, is that they contain exactly the same elements. That's what would make sets equal. So it's sort of like if you were talking about the same, one specific classroom of students and you said all the students that are in second grade as one set, and another set is all the students that went on the second grade field trip. As long as all the students went on the field trip, those are two different ways of referring to the same thing. Those would be considered equal sets. All right, then the last definition here on this page is the cardinal number. Your cardinal number, this is the number of elements in the set. So if we were looking at, the students that went on this field trip, maybe we don't necessarily care about all the individual names. Maybe we just care about how many of them actually went on the field trip. That would be the cardinal number. Another way to kind of summarize the information. All right, let's see a few more definitions. And we're going to compare something to equal sets, so keep this one in mind. The next one is equivalent sets. Typically, we use the words equal and equivalent to mean the same thing, but in the world of sets, they mean something different. So equal sets contained exactly the same elements. Equivalent sets have the same cardinal number. And as we just saw, cardinal number means the number of elements in the set. So we might just be concerned with, do these two sets have the same cardinal number? If they do, then they're equivalent sets. It's just another way to make comparisons between sets. And this, notation-wise, this is what you would see if these two sets had the same. The n on the outside of the parentheses just means the number of elements in set A, number of elements in set B. If you've got the equal sign in the middle, then they're equivalent sets. All right, two more definitions here. We have the empty set, which is also known as the null set. This is the set that contains no elements. Can be symbolized a couple different ways. The curly braces with nothing in the middle, so blank space in the middle of them, or a circle with a slash. So either of those two things would work. As a side note, putting the curly braces with the circle slash symbol inside is not the empty set. That is the set containing the circle with a slash through it. So that's not a way to do it. You can't use both of them. You have to pick one or the other. Okay, and then the last definition we'll see here is the universal set. This is symbolized by the letter U, and this is a set that contains all the elements for a specific discussion. The universal set is a helpful thing to have so that when we talk about sets inside of this universe, we don't have to worry about every single possible thing. We'll see more with universal sets in later videos, but just to give you an idea, if I say the universal set is all Valencia students, And then a set that I look at in the universe is students with a 3.5 GPA. Once I've set the universe, I know I'm only talking about Valencia students. So previously, if I had just said the set containing all students with a 3.5 GPA, it would have to be all students everywhere in the universe, in the world, blah, 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 that have a 3.5 GPA. But if I set the universe, it just says, here's the picture that I care about. Okay, now do some work inside of that. So the universe is just how we'll set things up. All right, so then let's do a little practice with these definitions to make sure you have a good understanding of them. So given the sets, answer the question. Some of them have more than one answer and some of them have no answer. So these are the given sets. We have A, B, C, D, and E. You can simply use those letters to answer. And then go ahead and answer each of the questions there. So are the sets presented with a description in roster form and set builder? Find a finite, find an infinite, all the way down to the last question. So go ahead and pause the video and then we'll go through these together in just a moment. Okay, so let's see if we're on the same page. First question, are the sets presented with a description in roster form or in set builder form? All 5 of these are presented in roster form. So I'm just going to circle it. Since they all have those curly braces and the elements specifically listed inside. The next one, find a finite set. You could have put one thing down, you could have put more than one, whatever works. But in fact, each one of these is a finite set. Remember, finite means it either has no elements or the number of elements is a natural number. We could count them. So A or B or C or D or E. It would have been fine if you put just one of them or if you listed all of them, but it only says to find a finite set. Okay, the next one is to find an infinite set. Every set is either finite or infinite, and infinite would mean that it goes on forever. The number of elements goes on forever, and we don't have any of those, so there's no answer here. The next one, find equal sets. Remember, equal sets means they contain exactly the same elements, not necessarily in the same order. For this one, we have one pair of equal sets, which would be A and D. Has to be these two together. When you're finding equal sets, you're comparing 2 together or more, but at least 2. The next one, find equivalent sets. So equivalent sets just means they contain the same number of items. So for this one, we have even more than 2. A and D and E all have the same number of elements. It would have been totally fine if you said any combination of these. If you said A and E, that works. If you said A and D, if you said D and A, whatever works, as long as you're conveying equivalent sets. Okay, the next one, find equivalent sets that aren't equal. So equivalent sets, meaning they have the same number of elements, that aren't equal, so they have different elements. So you had 2 choices here. You could have said A and E. They both contain 3 elements, but those elements are different. Or you could have said D and E. Each of these has 3 elements, but those elements are not the same. Some of them can be the same, they just can't be completely the same. All right, the next one. Find a set with cardinality 0, meaning there are 0 elements in it. That would be set B. The next one, create a set F that is equivalent to set C, but not equal. So we're creating a set F. You could have chose whatever form. I'm going to go with roster form. Equivalent to set C means it has the same number of elements, so 2 elements, but not equal. So those 2 elements could be anything. You could just say the numbers 1 and 2. You could have said 5 and 7. It doesn't even have to be numbers. You could pick words. You could say fun and fancy. Whatever works. It doesn't matter. There are 2 elements there, 2 elements there. They're equivalent but not equal. The next one, find an empty set. B is an empty set, has cardinality 0, contains no elements. And the last one, find a set with cardinality 3, meaning there are 3 elements in it. So you could have said A or D or E. One individually could have said all of them, but they wouldn't all have to be there. Compared to equal and equivalent sets, those earlier problems where you need to say A and D A and D and E, or this, a few different ways you can present it. All right, so in this video, we looked at those two objectives of using the three formats, the three methods of indicating sets. We went back and forth between roster, description, and set builder. And then we also learned some properties of sets and tested to make sure that those things were understood. So I will see you soon for another video.